Hi everyone, my name is Alexey and my colleague Artem. We would like to tell you on how we analyze dependencies in our development lifecycle, which challenges we faced, share our experience, and explain how we conquered over those obstacles. A couple of words about us. We are Appsec practitioners for quite a while. This is our second of zone presentation. I see familiar faces, people who saw our first presentation. It's great that Appsec is a popular topic that is interesting to many, not only to us. Well, we've been doing a number of researches in Appsec, and we're integrating some security practices into our development processes. We'll talk about open source and open source dependencies. It's everywhere now. It's used in many languages and many platforms. There's many packet managers for open source. For Java, you probably cannot even count, or for JavaScript, different managers, NPX, NPN, YARM, and others. In Python and Go, it's easier. The number of those packs is growing, and in 2018, Maven Center has grown. It has doubled in size, which is significant. It's very popular in development, and the reason is simple. Open source allows to significantly reduce the time for development, and everyone benefits from it. It's convenient, everyone is happy, but you need not forget about security. OWASP has A9.A9 of using components with known vulnerabilities, and it's appeared separately in 2013, and even though it is one of the last, it's number 9, it is still quite important and should not be ignored, as often, even in small projects, you can come across a lot of open source libraries, some of which will be deprecated and old and contain some CVEs. And statistically, even a small application can contain up to 60% of open source. So this is a widespread occurrence, and OWASP A9 happens quite often. Besides the dependencies that the developers use, there's a lot of indirect dependencies that trigger direct vulnerabilities from others. Like, have a look at this calculator app. It has dependencies with notifications and data processing that will also include 3 jars, and which one of them will be a MySQL library that our analyzer uses, and our application will be vulnerable even though we use 2 vulnerabilities, 2 dependencies that are not vulnerable. So this is non-secure. Statistically, 78% of CWE are in indirect dependencies. This is why it's so important to use specific tools designed for this and not rely on your competence and the libraries you've authored, and be able to monitor those indirect dependencies that are not vivid and obvious from the beginning. So use those special tools that create those lists and compare them to public CWEs. Open source security practice, OSS, is a practice aimed at securing the open source dependencies. This library has two approaches. First, it's just updating all the dependencies you have to the latest version. And we spend a lot of resources here to optimize the code, to add some functionality or optimize for it. But we also get a secure product, because often developers would add some fixes that don't have any public CWEs, and they will be closed in the update. So we close this risk. And second option is when we only update the libraries that have vulnerabilities. Of course, we spend less effort and time of developers, but we still have the risk of having bad bugs that are not closed, that are not public, and we have to cope with this. This slide has our main SDLC practices used. Last November, we were talking on how we've implemented SAST, statistical analysis. Now the colleagues are scaling and piloting test DST solutions, and now we are interested in OSS. It's situated in the beginning of our practices as the resource requirements are for implementation are no more than for SAST, and it's a baseline that does not replace SAST and have quite low false positive rate. Same as with SAST, we use quality gates, and same for SAST. The flexible quality gates are important. Small comparison of practices between OSS and SAST. First of all, with OSS, we don't need to scan the whole source code. Most of the time, it's enough to scan the configuration files to understand which libraries we use. jar, WAR, EAR files, so we don't analyze the whole code. And these instruments would use less time for analysis and less resources. Here comes the second point. More simple integration and deployment and support, as they don't scan the source code and only use the information about the libraries used, they work faster and require less resources. So we don't need to deploy some big setups or significant server load. In some cases, we can even use cloud solutions and not support our own infrastructure. And it's easier to fix bugs. Statistically, 97% CWEs have their fixes and or patches, and the developers can just update the library version and everything will be fine. Or in a more complex situation, just apply some patch. In a couple of cases, you would need to fix it by yourself or replace the library or even refrain from using it. But with SAST, we have a need to understand each and every bug, each and every defect, to understand how we can fix many of them. And the resource requirements are higher. With OSS, the false positive rate is lower because we use, for CWs, we use specific libraries that we take from configs, and the CVs are mapped to specific library versions, so compared with SUST it's simpler. And with some approaches, if we consolidate the results using the tools to merge them or triage them, we use custom false positive rules, then we can attain this zero false positive rate. Also, as this scanning is done fast, it doesn't scan the whole code, we can implement it as part of the build and without affecting the time to market, without affecting the team, and everyone would benefit from it. Also, to analyze the results, we don't need a team of experts. It's enough to have a qualified developer compared to SUST, where you often need a lot of time to make a decision about some bug. And spend a lot of time and resources for this. So you need technical expertise for this. So we've analyzed the experience of many companies and colleagues and understood the integration experience for different tools and identified 3 maturity levels for OSS integration into development process. First would be the simplest one, we call it OSS Classic. In essence, it implies having a separate Jenkins build that is triggered during the main build. It checkouts the code and runs the analysis, and we get the results. The main deployment builds the code, triggers our build, that runs the OSS, and then it reruns the build. So we don't need extra resources to support Jenkins, to support our separate checkout, etc. And we get those results separately from the main build, so we cannot affect it. We cannot use quality gates. So it's the simplest way, but not the most convenient one. Second option would be to integrate it into the pipe. And as our tool usually works quite fast, we can build the SUST analysis into the pipe, or dependency analysis into the OSS into the pipe, avoid deploying some specific infrastructure and spending resources on it. We just, during the main checkout and build stage, we run our scan and get the results, having the options to check the state of the pipeline, change it, use quality gates, avoid spending extra resources here. So it's a better option. And the third way, which we call proactive OSS, in essence, if you have information about the commands and libraries in use, for which projects, we can proactively monitor adding some CWEs to the prom and add our own rules, analyze library information, triage them, and find some massive CWEs, thus proactively helping the teams to fix the bugs on their side. looks quite simple. There's a project called Dependabot. Maybe someone knows it. It's part of GitHub now, and it's a proactive bot that analyzes the commits and the code, understands the outdated libraries, and if it finds them, it sends you a pull request for this repository with a fix. So if your project is not a special test project with old libraries, if you really want everything to be secure, then you can awk it and merge this pull with the get the fix with a secure updated libraries. So we hope that we will be able to create something like this for ourselves. It's cool stuff. And during the implementation of this practice for our company, we faced a lot of challenges. We understood we have a lot of teams, developers, a lot of programming languages, environments, stacks. And on the first stage, we had a classic approach. And with this approach, our builds were outdated very fast, and the scanning was set up in a way that the teams would have new repositories, branches, and make us waste our resources on the wrong results. So we decided we need to move to a pipeline approach and DevOps, and thus as there were only two people, Artem and myself, doing all that integration, we needed a flexible and scalable solution that we would be able to apply to a lot of developers and builds. We faced challenges, the same challenges when we were integrating SAST, and here we actually went the same way by formulating the main requirements, same as with SAST. We need to have a service that the team will be able to attach for their build themselves without any actions from our side. So we need to have Confluence portal description that the team will be able to run it themselves if they wish to be more secure. And also, in our case, we have a closed segment, so we cannot use any external internet resources. We can't use a lot of cloud solutions, library hashes, stuff like that. So our solution needs to be flexible and agile and scalable and support quality gates to work inside the internal segment. We've analyzed a lot of tools, tested them, both commercial and free, and a real pro for the tools we saw was to support the base vulnerabilities. Many companies would have their own teams doing research, and those teams are checking public repositories of open source for having new defects that don't have CWE, actualize the base, which is cool. Also, many of those tools, commercial tools, would have licensing checks integrated, which is also very useful and is often needed. With open source, specifically with OWASP dependency checker. If you haven't seen it, have a look. Was dependency checker had a lot of benefits. It's as it's an open source, it has you can look at the code, and the commercial tools would often have some difficulties we cannot solve without working with a vendor. You need to work together with them, and with Odyssey, you see code. You can run some fix on your site. If it's useful for everyone, then you can commit it to the community. Use a custom plugin version only for yourself, which is also fine as until our case is updated, then it is not published, and we can use the community help. And with Odyssey, it can work offline. It can download offline database, which it uses. We just update it once every 24 hours. And we are fine with this. With Odyssey, it has a lot of integration with different tools and platforms, and also its big plus is cool integration with Jenkins. Jenkins plugin that has Odyssey core. So we don't need with Jenkins to deploy our separate server, support it, monitor its availability. The whole analysis is done on the Teams side using Jenkins agent, and we save our resources, we save our time. And this tool works very fast, so we like it, and we're really happy with using it. Also, after comparing the results of those tools, we are satisfied with Odyssey results and decided to use it. We are happy with it. In essence, by choosing Odyssey, we started thinking how we can integrate it into existing infrastructure in the solutions we were creating for SAST, for everything to be working flawlessly, how we can integrate it with security application lifecycle management. Every company has a security manager, so we also have it. And we went the SAST way, using the shared library in Groove and integrating it. And Artem will talk a bit about the challenges we faced in integration. Hi everyone. I see known faces in the hall, so at least some of people would know how the process works in our DevSecOps, and for those who don't, I will briefly tell the story. All the members of our infrastructure are represented here. Our CI manager, Jenkins, CVS version control, from which the in the command pipeline the code is checked out. Then they import our Groove library that calls our security application lifecycle manager, where different meta information is sent. Part of it is taken from our Jenkins workspace. It's a hash of the current code, it's a branch and repository, and some of the metadata is read from the repository through YAML file that the teams place into their code. to be integrated in DevSecOps. Using this information, the SAM would decide whether we need to scan this code. If we scanned it previously, then we don't need to rescan it. But if we need the scanning, it sends back the green light, the OK, and the code goes to some of the checkmarks manager, and the information about which checkmarks manager should be used is sent by SAM, and we use a number of them to understand the load, and as checkmarks has a limitation on the number of threads it can scan. And in the end, by using the integrated tool for checkmarks, the SAM curves the Jenkins curves the SAM and checks, and it is a source of information for different sources, services like quality gates and analytic systems. By doing this, we've covered 90% of the teams in our company. 90% of pipes are integrated, have our library integrated in their pipe. We had to use it definitely, as it's a huge baseline to begin with, and we added another function into our library that, besides using SUST, was also using OSS. So we have a plugin for dependency checker, for OWASP dependency checker, as SUST is a prerequisite. If you are connected to SUST, you can add OSS. The plugin takes the source code from the workspace, builds the dependencies, gathers the dependencies that are used in the source code, goes to an offline database. We have two databases in the offline. The first of them is Ministry of Interior, and second is a JSON for GS that is their database. We just sent it over web. The plugin itself maps the dependencies to the vulnerabilities, generates the report that we read and send to SELM. Now SELM can also reply to requests from quality gates, provide analytics, and be an interface for triage for the teams. Which user stories the team and us as Appsec team have? What does the team need to add Appsec? They just need to add one string. They need to want it, of course. They need to add one string to their config saying run SCX, then sends the config, runs SCX, and the repository or the branch or the hash commit. Now you just need to copy this line, change the function name, and now they are integrated with OSS practice. Then, after the scanning is complete, they will get a letter with a link to our SELM. They will go to an interface for defects analysis, mark the false positives, false negatives, and voila, they have results. They know whether they are protected. For us as an Appsec team, we need to keep improving and raising the true positive rate and ensure that we have less falses and update the databases. So we do it roughly once and copy this to our internal segment and use this file. But there are negatives here in this solution. OWASP dependency checker does not have any UI to sort through the defects. despite unlike the commercial products that have such an interface where you can read through a lot of the defects and sort them. So OWASP Dependency Checker doesn't provide anything like this. We had a solution starting from OSS Classic. We had such a web interface where you could sort through the defects. SOM is not only the DevSecOps orchestrator, it's also has a web interface where you can manage the different practices and organize analytics and configure stuff.
And we've changed this interface. We've added the function of adding new users. We map them for their projects automatically. To get access to these projects, they simply go to follow the link from email, log in according to their data, and they get the possibility of to triage their own defects. They choose the false positive defect. Do they need to fix it or not? They can export their results into the tracker to filter it somehow, and by doing this, we have solved the problem with UI. We, as a company, are using the quality gate in practice. And we decided to build them exactly in a way as we have done it for SAST. Basically, these are kind of threshold norms based on the number of defects, of the high defects and the mid-level and the low-level defects. And here we have a question: how do we map defects from MPD for like their criticality? There is a CVSS rating tool. We've used the CVSS 2.0, which enables to map the three critical levels: low, medium, and high level. Works very simply. We're looking at what the range of our score, base score range, and get the criticality level. There is the same rating in the 3.0 version. It has 4 levels. There is also a critical level from 9 to 10. And for our purposes, I would say that these 3 low, medium, and high levels are quite enough. We also have a problem. We have some defects which do not have any CVSS scores, like retard.js or OpenSSL Analyzer, which is available in Dependency Checker. We simply consider this to be the very high severity. The percentage is not very high in the total number of defects, so it's not a big problem for teams to sort out these defects. We believe it's quite admissible practice. Now, as for using quality gates and the OSS practice in general, we believe it's quite okay, because OSS has the low false positive rate, so this should find understanding with developers. Quality gates for teams look like 2 REST API. One of them is the status one for a particular build assembly, and the second one will give us the values whether we've gone through a certain stage. Is our assembly passing our own criteria and norms, and does it pass through a high criteria and mid criteria level? And the team is passing commit hash and gets one of these results, and then the teams may use these values for laying on the flats, Nexus, or somewhere else, maybe into other accounting system, reporting system. And when implementing our approach, we faced a number of challenges, which we were able to solve to a certain extent. And I guess the number one we had to deal with is the Jenkins plugin for ODC. By default, basically all important things are being configured in it, like in the global Jenkins settings. In a situation when I have a lot of Jenkins with the whole bunch and agents, which are on different operational systems, and part of them can belong to teams, and who knows who is administrating these agents and or Jenkins. It's all becoming quite complex, because you have to communicate somehow with when updating, let's say, URL or connection string to offline database, you have to ask everyone, can I correct it here, update it here? This process is not easy. It cannot be supported, so we decided to add such an option to be able to configure these settings, namely connecting database, be it a local return.js file in a local network, and some settings, for example, the path to a database driver to connect to an offline database. We've also added them as options to call Jenkins plugin, and now we can configure all of these things out of the pipeline. We pulled this PR into the plugin, but the main contributor did not accept it, thinking that this will not be very secure to give away configuration all the way to BD or database by the initiator. I would agree with that, but in our case, since this code is encapsulated in our own library, it does not carry any risk with it, and therefore we are using our own customized version where we are configuring it in such a way. The second challenge we had to deal with is that ODC, sometimes the kernel can actually drop, and it affects pipeline command, which is unthinkable, which is not allowable because we as a service have to be very reliable, have to be very friendly for that matter. And in Jenkins, if you drop your own pipeline, you cannot make it green again. This is like one of the specs of the Jenkins. You can always make it just worse. So we added one more flag, enabling us to launch analyzers in such a way that by no means it will drop the pipeline. And this PR was accepted. I think it has been issued in a new version of the plugin. The third thing, it was not all that great with an offline support, and for example, the PM analyzer does not work in the closed network segments. The point is that the general logic of the analyzer in Odyssey, RPM analyzer, it does the same thing as the npm audit call is making. It takes your JSON package and sends it to a server of an IPM, where it's mapping your dependencies and returning you a report. So there's no real support here. And we weren't able to find this npm database with vulnerabilities anywhere. And here we do not know how to solve this problem yet. As with Nexus, in their public tracker, there is a request for them to be able to somehow to proxy these calls, this command, but so far it has not been resolved. And maybe they'll be able to resolve this problem even before we do. Also, Jenkins plugin for Odyssey does not have a support of any support of excludes. Therefore, we had to add this custom function to be able to exclude files. And what was the origin of this problem? A number of team in workspace, they had huge files with some kind of binaries and, I don't know, logs. Well, actually, speaking about archives, and the logic of the Odyssey is such that it takes any archives and begins to extract them. For example, the team had a very low tempo, and this process was basically freezing a lot. So the scanning, which should be taking 30 seconds, would take 5 minutes. And then, as a matter of fact, the system would freeze because there was no space in this segment, and you could do nothing with it. So we added the excluding mechanism. It supports and style patterns. You can exclude some particular extensions, or you can exclude directories. We've again pulled this PR and waiting for this to be merged. On the bottom, you can see the link to a plugin. You can check out this PR. And if you'll need to use this functionality, which didn't make it up to the main thread, you can actually merge it for yourself and to use it. Throughout implementing this approach, we had a number of intentions, number of goals, intentions, or wishes I would like to share about them, and probably the commercial ventures or contributors will implement it in as an open source in whatever format. Number one is the full support of closed network segments, so that companies would be able to use analyzers either in their own closed networks or in the networks without internet access. Number of companies simply do not want in any way, shape, or form to communicate what components they use, neither in titles of libraries nor in hash forms. So the cloud solutions here simply do not work. And the second desire of ours is simply to provide a support of very rare technologies, such as open source analyzing for Delphi or Go. And that's a little whim of ours. And to sum it up, all that I've been speaking about, some pros and cons of this approach. Out of pros, it's free. Second thing being that this is incredible flexibility. We can use any of the available ways of integration, be it Jenkins on CLI or other analyzer. And we can change the product just how we want it. Like we've seen, we can implement different features which are not there in the main version and to use them. And that would not be the case with a vendor-issued product, or even if it did, we would get this functionality in a month. In ODC, there's a good number of analyzers, and basically we're fine with it, with the number and with the volume of being supported. And since the main language of development is Java, it still covers very well our functionality. It works quite well in close network segments. It can find indirect dependencies, which is very important, as Alexey demonstrated. Was it 78% of cases? It launches on our CI manager in Jenkins. Again, it's another advantage, and it has incredible speed of operation in 30 seconds. It's working through, plowing through 2 million lines of code. It doesn't matter how many lines, it's just working 30 seconds, it seems, with any segment. Now the cons. It's quite difficult to configure it on large infrastructure. We have a lot of Jenkins, when I have a lot of agents, so with different operational systems. And like in any open source, it has some bugs in it, but you have to deal with it because it's free. And we are fixing these bugs, and in this way contribute to the open source. Again, there is no vendor support. Sometimes you really want to feel like, guys, could you please fix this, and not to do it yourselves. But it's it's a give and take. And there is no support of license checks. We do not need it. It's work of a certain compliance function. But some people, individuals, organizations may find it interesting. There is no UI, but I've already mentioned how we were able to bypass this problem. Now, how do we want to develop our approach in the future? What do we want to do next to make sure that our solution becomes better and better? First of all, I would like to solve the problem with the NPM analyzer. We do not know yet how to even get around this problem, but we are thinking that we'll be able to solve this problem, and we'll be able to analyze NPR packages in the closed segments. We want to improve our triage process to make it better, to make interface better, maybe to add some confidence level, machine learning possibly, and help teams what could be the false positive and what is not. We also could add some custom analytics and possibilities for us to be able to to set certain vulnerability as a true positive in case if we understand that this is going to work with everyone else. Also, what we would need is some custom false positive or true positive rules. This could be very good when a team understands that this library never has anything off because they use it only in the test environment or in reality it does not exist. This would be like a very good fact. And also we want to develop our proactive approach. We've accumulated quite a good database already where we can map different apps for particular components. And so we, on very early stage, can alarm teams that any certain assembly or build, there is a new vulnerability popped up in a certain component. Are you using this component? If yes, guys, do something without launching your pipeline. And also, we'd like to add support of some custom vulnerabilities. This could be again very good in this kind of practice-based approach when we know that certain components have 0 or 1 day vulnerabilities, which has not yet made its way in some public databases, but the general public does not know it yet. We can add it in a customized way, and again, the teams will learn about it before the launch of the pipeline. And this could also be very good in terms of we have some internal components. If we know somehow, if we learn somehow from the practice that our internal component, which is being developed somewhere in the company, there is a bug, there is a mistake, we would like to notify all the teams using this component to make sure don't do it, patch it up, use the newer, updated version. And I always want to share and promise that we will share our library, make it public, and now it's a custom type of library that we cannot show it yet. There is a token being stored also in all the things. Yeah, this kind of passwords, but when I'll make it more like generalized, I think some will find it very useful. Thank you for coming.